Hello everyone. So welcome back, and we are back with the lecture of generative AI. So today we are just going to see something interesting. But first, let's start with the story. Okay, so let's start. Okay, so I hope that you all have watched the Tom and Jerry. So GAN is something like that a mouse is actually running and cat is actually doing like chasing it. Okay, so in the context of GAN, what is the mouse, guys? Is it a generator or is it a discriminator? So okay, first listen this story, very short story. Like you know from the house of Jerry, Tom has stolen something, and then he's running. Okay, so he's running after the mouse, and you have to tell that which one is generator and which one is discriminator. Okay, so and you'll get the answer, of course, in the next video. But yeah, you can just write in the comments. Fine. Now, Now let's see the very interesting thing about GAN. We in the previous video, if you have watched, then we have talked about some disadvantages of the normal GAN. You can see here now. Um, okay, generator overpowers the discriminator, something like that, or discriminator is overpowering. Just like you can see this, like maybe discriminator is over the generator, or maybe generator is over the discriminator. So these are some issues that we have to see, and there is uninformative loss is also there. So these are a lot of challenges in the GAN. To address that, there was one very interesting paper that came in 2017. You can see here, in the 2017, they actually it was a very big step towards stabilizing the GAN training. So we will be seeing that what is the thing they have introduced. So just see it overview. Okay, that it correlates the generator convergence and sample quality. Okay, so they are actually um, taking the loss metric. They are putting the new loss metric. Then they have also improved the stability in the optimization process. Fine. So okay, they have actually introduced the vegetarian loss function for both discriminator and generator. Okay, that is the important point, guys. And instead of the binary cross entropy, they have used something else. Fine. So we'll be seeing that just in a while. Yeah. So this is the short notes, guys, about WGAN. So we call it WGAN, means Wasserstein GAN. Okay, with the gradient penalty. So today will be saying that what is the WGAN, and then next video what will be, and this video is going to be fully theoretical. Fine. So let's start. Um, okay. So just seeing the traditional GAN loss functions, this is the loss function, and this is binary cross entropy, guys. Okay, in it, like I just want to summarize it in a very few words. Like discriminator was telling that if it is a what the discriminator does, it discriminates. Okay, so what it does, it discriminates. So let's discriminator have two samples, and if it is a real sample, then what it will be predicting, it will be one or close to one. But if it is fake, then it will be predicting zero. That is the work of the discriminator. Okay, but they have changed something, and we'll be seeing now. And Like in the generator loss, discriminator to like it wants discriminator to think that fake images are real and something like that. But the major change was there. Okay, I just want to show you. The major change was there. Like discriminator was now for the real images, it gives one, but there is a change, guys. For the fake images, it gives -1. Just a slight change you can see here. Just a slight change. It's a 0 and -1. But -1 is the penalty. It is something that is called penalty, and that was quite important and a very a small thing, but it makes a very big difference. Why it makes a very big difference? Because now the discriminator is called critic. It is not no more only a discriminator. It is actually a critic, that okay, if you are fake, then you are going to get the negative points. Then the fake images will be the loss function will be more. Okay, there will be more loss in terms of if it is fake. So that was the thing. There is of course mathematical functions change over there, but we are more focusing on now the thing that is more towards like what they have done. So two things were done. First thing was this discriminator function, and second thing was uh, they have removed the sigmoid function on the output layer. Before the output layer, they had a sigmoid function. So this is the sigmoid function, guys. This is the sigmoid function, and it what it makes. What is the use of sigmoid function? It makes all the outputs just to in between 0 to 1. Okay, so 0 to 1, they just squeeze it. Okay, this is the function. And I just want to write the function of this is the sigmoid function. Okay, so but they have removed it. So what is actually been done after the removal? After the removal, there will be minus infinite to infinite. Y predicted will become the minus infinite to infinite. That was only 0 to 1. So this was old and this is new. So there was two main things happened, and that is the point, guys. And this is quite a small video, so that your understanding will be very concrete. What is the WGAN, and then we'll be seeing the what is the gradient penalty. So this was the thing, guys, and that was all about WGAN. And please tell in the comments that which is the generator, which is the discriminator. And meet you in the next video with gradient penalty. And see you soon, guys.